Before we get into the video of where I'm building this, I decided to show you the finished product and a couple things that come up in the video that you may want to do different. So first off, in the video I use these saddle tees that can kind of bend up and down. In the end, I'm not actually super happy with that. When I do the level 2 launcher, which is the next video I'll upload, I end up just using tees and gluing it in, and it's much more rigid and stable. So even though I use the saddle tees for this basic launcher, I think I would have preferred to use regular tees that glued in. Keep in mind that that then meant I had to cut it open and glue in 2 tees and reassemble it so that it was all straight. So that's one change from the video. I'll do a couple close-ups here to show you what we end up making. Here's the hole, the 9/16 hole that I drilled into the cap that has the valve stem. And here's the bulge that I made. You can see it's a straight pipe and then it kind of bulges out a little bit. I burned it slightly, not too much to worry about. And that's what it looks like from the side. The level 2 one, it's the same thing, 9/16 hole, and I glued in the tees and some caps on the feet. I'm much happier with this. And then there's that mechanism, which I'll show you in the next video. So there we go. So once you have a rocket, we're going to want to be able to make a rocket launcher. So what I have found is 1/2" PVC fits very nicely into a bottle and can be used to make your launcher. Now there's quite a few plans online for lots of different styles of launchers. I've made a few of them and they have different advantages and disadvantages. Ultimately I've come to this design as one that I like because it's the parts seem to be easier to find. Some of them have you use O-rings. US water rockets, they have some great videos, some great instructions, great ideas for fins if you're looking for some other ideas. And they have a design where they slide inside PVC pipe, a smaller pipe, an O-ring goes around it against a little union coupling. It looked great, but then of course trying to find the set O-rings and pipe that would fit inside, I had problems. And when you get the PVC, you will find that some of them are a thick wall and some are a thin wall, and that'll affect other things. So for this design, I'm using a mixture of thick and thin just based on scraps that I have. I don't think it'll really matter. So I like this design because it's simple, and you'll find that you can make all of it just with stuff that you could get at a local hardware store and easily. So we're going to start by using a candle to heat up the PVC to try and make a ridge so that when the bottle slides on it, it can only go so far and then seals. We want to make sure that when we're heating it up, we're going to be compressing it and that we don't get a huge ridge, sort of a big ridge. It's going to be a little hard to see from there, but you don't want to push and have it so hard that when you push it together, it makes this big ridge. You also avoid getting it all bubbly and black. I'll show you what I mean by that in the techniques, but here's the idea. Right now, the bottle can slide all the way through. There's nothing stopping the bottle. So we're going to heat this up over the flame of the candle. Now the hottest spot of the flame is above, not in the flame anyway. So if you're trying to heat it up, it's above the flame. You don't want it to get all black and smoky, but as we heat it up, I'm rotating it like a rotisserie right now, just along with my fingers. It's going a little bit yellow, that's okay. It's telling me that it's getting hot. As it heats up, it'll get soft. So it's starting to slightly melt. And I will be able to push from each end, causing it to bulge out. Sometimes I kind of just sort of wiggle it a little bit. It's a little bit bendy. Oh, I got a little too hot, started to bubble. Don't want bubbles. It's not a big deal if there's a few bubbles. It just means I have to sand them out with some sandpaper. Again, got it too hot. Mine's not going to be beautiful, but that's okay. I'll sand it afterwards. Okay, so it's bendy. So now I'm going to push from both ends, trying to keep it exactly straight, not letting it bend all over. This is the kind of thing that your hand-eye coordination will reveal. It might go all bendy and bent and around, and that's okay. Cut another piece, do it again, or try and straighten it back out, use some sandpaper. The main thing I'm trying to make sure is that it's straight. That's the main thing I want, is that it's straight, not bent. I'm just kind of pushing from each end as it cools, turning it a little bit with my hand so that I can see that it's pretty straight. Oh, that's got a bend there, so bend it back. So it's created a little bit of a bulge in the pipe. So now when I go to slide the bottle on, it won't be able to slide the whole way because it's hitting this bulge. I don't want the bulge too big. If it's too big, then the bottle just kind of sits against it. I'm wanting it that the bottle kind of slides around the shoulder of that bulge and seals up and creates a nice seal. You can see I got mine a little bit too hot and it's got these little black spots. Not a big deal, but that makes it kind of rough, and then air can sometimes escape, so then you use sandpaper and get it kind of smooth, but you don't sandpaper too much. Okay, so that's that part. That's where the bottle will be on, and it seals against that. It won't fall off. That's good. Blow the candle out. So with my piece of PVC pipe, I need a 45, half-inch 45. Grab another length of 8-inch, 20 centimeters or so, plus or minus, and then a 45 degree. So we have a 90 degree, and then half of that, a 45 degree. And then I have a short little piece like this. Now I haven't put any glue. I do have glue, I'll glue it later. I like to get all the pieces, make sure they're the right size first, glue at the end. And now I need a way to put air into this so that it'll pressurize, and if I have some water in the bottle as well, that when it releases, it'll go up really high. So the way I'm going to do that is use a tubeless valve stem. I got these, I think, at Canadian Tire or something like that. These are 0.453, so this 0.453 is just referring to the diameter of the stem, not the part that has to go, that I'm going to be able to seal against. And so I've tried a few different sizes, and I have found a 9/16 is a little tight, but it actually seems to work the best. So that's the one I'm going to try. I can always go a little bit bigger if it doesn't work on this one here. So here we go. I am going to try and make something like this, where I take a cap, I drill a hole through it, and I get the valve stem to go through and get stuck like that. So goggles on, safety. I'll take a cap. Some of these caps have like a little plastic knob on the inside that makes them really hard to drill out. So I don't recommend it if they have this little plastic insert in there. And then some of them are nice and smooth on the inside. I have a vise here. I'll compress it. I'm not going to squish it so hard that it's super tight, but enough that it's holding it there. 9/16. And I'll just try and go in the center. It's nice if I'm not off to the side, but just in the center. You might, when you're buying parts, you might want a couple extra caps. That way if something messes up. I'm not pushing too hard. I don't want this thing to blow through and break something. It emits a bit of a funny smell when you're drilling it. My old biology in me, I only take a couple biology courses. I'm thinking it's esters. When you heat up plastic and you get a smell, it could be totally wrong. Some biology person out there might. What is that smell that I smell when I'm drilling plastic? Okay, I didn't get it perfectly in the center. I think there's enough plastic that it'll grab on. Kind of wish I was a bit more centered, but anyways, I'll push this through. You need some strong hands for this. Kind of rocking it around. better if I was more in the center. Yeah, there, I got it. It worked. I did this one here a little bit more in the center. When I actually did it, it popped into place. Like, it feels like it popped. This one's, that's pretty good though. Oh yeah, no, that's in now. Okay, so that's good. Got a couple here. Yeah, you're going to need 5 of these end caps anyways, just for when you make the or get a couple extra, just in case they don't go in exactly how you want. But that's the idea. Okay, so now I can glue this on there. Okay, I'm going to use this one. I like this one better. It fits better. So this is the most important part. I can take the bicycle pump, I can pump on here, air will go in, go up and through here, go up into the bottle, pressurize the bottle. The more I pump, the more pressure, and if I've pushed this bottle down on this little shoulder, it doesn't want to come off until it gets enough pressure and it blows it off. This is sort of a level 1 design. There's some things we can do to make this even better, but to start, this would work for everyone. You just push that bottle down, pump it up, pump up the pressure enough that it's able to break free and blow off. But we don't want it to be all floppy, so we need a way for it to stand up. So the simplest way is to use regular tees. You can cut this in half and use shorter pieces. Another way, that sometimes I find a little bit more elegant or whatever, but these parts are hard to find. I have made them. It was really scary on the table saw. I don't recommend making these. But if you are able to find, they're a couple more dollars. It's called a saddle tee. And so what happens with this tee is it's able to pop around an existing pipe. And that then enables you to have your feet. Let's get one more here. The same length, so that it's foldable and it makes it go into storage a little bit better, and then you can do this kind of thing and launch it. So those are saddle tees if you want it to be sort of compact or at least adjustable. Otherwise, cut whatever lengths you want to be able to create a couple feet out there using a couple just regular tees. Regular tees work fine. If you're not needing to store it in a tight spot, I mean, you can always just hang it on the wall anyways, whatever design. I'm going to make most of mine just out of regular tees. Back in the day though, I wanted this, I picked up a bunch of these saddle tees because I wanted to make it collapsible, a fancy feature. Yeah, so now it's going to be to glue this all together and launch it, and then I'll show you the level 2, how we can tweak this design to make it even better. But first, let's glue things together. So make sure you have some paper towel that you can use. Work over top of some paper towel or a rag or something like that. Have some extra paper towel handy. And I'm going to glue this end first. So I have a short piece, 4 centimeters or 4 inches, 10 centimeters, and I'm going to glue it first. Need a wrench. I could not get this open with my hands. I ended up having to go get a wrench so I could get this thing open. And now I have it open. So I have a short piece of 1/2-inch PVC, a 1/2-inch cap. I've drilled a 9/16 hole, and I've pulled through this 0.453 valve stem for a tubeless tire. And I don't want to, this is a tricky one, because this isn't a perfect seal in here, I kind of want enough glue that it'll go around the edge, but not so much that it'll inadvertently plug the hole. So I'll show you how I'm going to handle that. I will work over the paper towel. I'll put a little bit here. I also got the clear glue. Usually the default seems to be this gray glue, which is kind of ugly, but I found the clear, which I prefer. So as I put this in, I'm going to turn a circle. So it's turning a circle, turning a circle. And then I'm going to push it as hard as I can. I'm not pushing on the valve stem, I'm pushing on this, with the idea that this pipe is pushing up against the edge of that valve stem, but not squishing any glue. And I'm going to leave this one upright like this. So if inadvertently any glue did get in there on that, the hole of the valve stem where the air goes through, at least it'll be dripping down the other direction. And then you can leave the big blob of glue, or if you don't want it on there, you can wipe off all this excess. You can use a rag straight on it or paper towel straight on it, that way you don't have to touch it, I guess. It's probably better. Good. So I did a circular motion as I put it in to make sure glue was getting everywhere. I pushed down really hard on this 1/2 inch valve stem to try and push this piece of pipe up against the rubber of the valve stem, and I let it dry this way so that no glue inadvertently gets on top of that mount. It'd be unlikely. You'd have to have a lot of glue in there to have it on top of the valve stem. So that's for that end. Now I want to glue this together in such a way that it all makes a nice perfect straight line. So a few things don't matter what I do. This one doesn't matter because I can always rotate it. So I'm going to glue this end first here. So a little glue around the edge. Maybe not as much this time. Do my circle, turning it as I put it on. Pushing it together. Okay. As well, these two don't matter because I can always turn it. So I'll put this one on. I don't have to think about it too much. Turning it as I put it in there, turning it as I put it in, pushing it together as I turn it. A little bit dripped off, it's okay, it landed on the paper towel. Now, for putting these two, I have to be thinking. Again, it doesn't matter when this one, I can always turn it afterwards. So I can put this one on. There. Now this last one does matter. I can't just put it on really nilly and have, well, actually you could even launch it. Maybe this would be easier if the thing was off to the side. I've never thought about doing that as a design. I like it straight up and down. I'm going to make it straight because I think it'll look better, but now that I see it, I kind of go, oh, maybe that would be cool. You'd pump your bicycle pump off to the side. I don't know. I'll stick to the plan. Plan is this way. So, I'll clear out a spot to put it. Put a piece of paper towel down for anything that might drip. Okay. Put it on this pipe here. I'm not going to come straight on. I'm going to come from the side, turn it, and then kind of line things up. There. So I'm using the flat of the table to make it flat. Good. I'll use saddle tees on this one, and then on the next one, when I do the level 2 style, I'll use the regular tees, just because I have a couple of these saddle. Okay, there, it stands up. Now, I like using the Tees on here because sometimes it's nice to put even like a little extra pipe, like a foot. You know, you can get more and more elaborate so that it is more stable. Sometimes you get a really heavy bottle on there and the whole thing tips over and so on. That's why these saddle tees actually aren't great, because sometimes when you're putting the bottle on, the whole thing tips and you got to straighten it back out. But I have some, so I'm using them, that's all. Hey, that's the idea. So you design it how complicated you want to get it or how simple you want to get it. And then we can put the bottle on, get a bicycle pump it up. Actually, let's go launch this and just see how well this works with just a bottle. Okay, so remember, this is the level 1 design. I'm definitely wearing goggles. I'm gonna pump this up, and it just goes when it reaches enough pressure. I don't have any control about the release. Oh! So it works. The level 1, straightforward, little heat, little glue, some basic pipes, it works. And if I wanted to have more pressure, I could push this bottle down, I could push it even harder, and so on. I can see that my launcher here is not perfectly vertical. It's got a slight crook to it. I could heat it up, try and straighten it. I'm not going to worry about it.